The paper of the day is Concurrency Control Performance Modeling, Alternatives and Implications. This paper takes an in-depth look at the performance implications of varying concurrency control algorithms. Specifically, it examines the performance of three concurrency methods: blocking, immediate restart, and optimistic. In the blocking algorithm, all transactions set locks on objects that are read or written. Whenever a lock request is denied, the requesting transaction is placed in a waiting queue until it can be processed. On deadlock, the youngest transaction is restarted. With immediate restart transactions, again, acquire locks on objects. In this case, however, if the transaction is blocked, it is immediately restarted with some delay. For the optimistic case, all transactions are allowed to proceed as if no conflicts occur. Only if a conflict is detected at commit time, a transaction is restarted. Let's look at these three categories in detail. So blocking. Transactions set read locks on objects that they read, and these locks are later upgraded to write locks for objects that they also write. If a lock request is denied, the requesting transaction is blocked. The waits for transaction is maintained, and deadlock detection is performed each time a transaction blocks. If a deadlock is discovered, the youngest transaction in the deadlock cycle is chosen as the victim and restarted. The dynamic two-phase locking is an example of this strategy. Immediate restart. As in the case of blocking, transactions read lock the objects that they read, and they later upgrade these locks to write locks for objects that they also write. However, if a lock is denied, the requesting transaction is aborted and then restarted after a restart delay. The delay period, which should be in the order of the expected response time of a transaction, prevents the same conflict from occurring repeatedly. Optimistic. Transactions are allowed to execute unhindered and are validated only after they have reached their commit points. A transaction is restarted at the commit point if it finds that any object that it read has been written by another transaction that committed during its lifetime. Simulation results. Using the model developed in the paper, a simulation of each concurrency control algorithm using the varying numbers of resources is performed at different concurrency levels. It is shown that at infinite resources level, the optimistic method outperforms blocking, while with scarce resources, blocking outperforms optimistic. That is, if you expect high resource utilization of your hardware, blocking is better choice. If you expect low resource utilization, optimistic concurrency is a better choice. Ultimately, there is no one-size-fits-all solution, and different concurrency models are better for different workloads and environments. Contribution. One specific conclusion of this study is that a concurrency control algorithm that tends to conserve physical resources by blocking transactions that might otherwise have to be restarted is a better choice than a restart-oriented algorithm in an environment where physical resources are limited. Dynamic two-phase locking has found to outperform the immediate restart and optimistic algorithms for medium to high levels of resource utilization. However, if resource utilization are low enough so that a large amount of wasted resources can be tolerated, and in addition, there are a large number of transactions available to execute, then the restart-oriented algorithm that allows a higher degree of concurrent execution is a better choice. Authors found the optimistic algorithm to perform the best of the three algorithms tested under these conditions. Low resource utilizations such as these could arise in a database machine with a large number of CPUs and disks with a number of users, similar to those of today's mediums to large time sharing systems. They could also arise in primarily interactive applications in which large think times are common and in which the number of users is just that the utilization of the system is low as a result.